I'm back to teach you more about God's true circle. Have you ever been taught the 1-inch circumference circle? I mean, you would think it's important. We were taught the 1-inch diameter circle. It's important. We were taught the 1-inch radius circle. It's important. So why don't they teach the 1-inch circumference circle? Surely it's important. Well, it's because they use a false scale pi. So the measurements inside that 1-inch circumference circle really don't mean anything. But I'm here to show you the true 1-inch circumference circle, how awesome it is, and how the circle grows from that value. This is a replica of the 1-inch circumference circle. And if you're new to the channel, dividing the 360 degrees of the circle by the true value of pi is the same as dividing the equilateral triangle from a 3.6-inch hypotenuse. They're linked because they have the same thing in common. The 60-degree portion of the circle is the hypotenuse of the equilateral triangle. This 120-degree back angle goes with this 120 degrees of the circle, and whenever you multiply the diameter by the equilateral triangle height, it will equal this length's square, linking them together. In the 1-inch circumference circle, the reflection number, the diameter multiplied by the equilateral triangle height, equals 0.0771604,938. That's 0.27 repeating squared. But also this value, might not look familiar, is also a fraction of 1/12.96. So whenever the circle grows from 1 inch to 3.6 inches, the 60-degree portion of the circle, which is the hypotenuse of the equilateral triangle, will equal the value of 1. And the diameter multiplied by the equilateral triangle height will also equal 1. How this circle grows from this fraction, let's take for example the 30-degree portion. Whenever its value is 1, this portion is also equal to the radius of the circle, but whenever its value is 1, the circumference is equal to the square root of 38.88. And if you take this value and multiply it by 38.88, you'll see that you get the answer of 3, which is the square of the 60-degree portion, the hypotenuse of the equilateral triangle's position. And also, whenever you multiply the diameter, which is 2, by the equilateral triangle height, which is equal to 1.5, you'll get 3. Side note, rational squares mess with rational squares. If it makes a rational square on the inside, on the circumference at that same spot, it'll create a rational square.